So what I want to do is create a rotocasting machine for my mold. And this basically will coat the inside of the mold with the material. So I thought, somebody's already created one. Why can't I make one? All I need are the right parts. So it looked pretty simple to me. I could probably get all those parts and 3D print the ones that I needed and cut the boards to the lengths that he was talking about. I said, I think I can do this. And then all I need to do is hook up some sort of motor and drive the machine. So I set out to build everything, and I got it started. Okay, so we're going to put together this outer frame.
Are you going to need help with this? Or?
No, I'll be right.
All right.
Thank you. Nuts. Bolts. Need to make sure this is in the center. Alright, pulleys in the center.
Hanging over too.
I just don't think it's right.
His are hanging over.
Shouldn't be. Inner frame, inside the outer frame.
Right, and then you would actually thread the nut down to here to tighten up.
But yeah.
So it's got a nut here, and then it's got to have a nut on the top of it where you attaches your gear. So it's two nuts.
No, hang on. Oh really?
Okay.
I'm thinking that it's just a bearing there. Center hole out.
Then what?
What?
All right, I need to send an email right quick about the instructions.
This guy. Mold.
those eyes in there so tight like that?
Now, the problem is, I thought these were 12, should have been 12 inches. They're supposed to be 10 inches.
Oh.
So,
You might need to recut.
but see, the problem is I can't really recut because this thing is about 12 inches.
I'll have to catch up to what you're saying. Can I say that again, man?
I could cut some slots into this wood so that it would be able to go through.
Oh, just to get the eyes on the other side?
Yeah.
You can't even work it at an angle? No. Oh, you got eyes on both sides.
Yeah.
You take the eyes out and put them back.
No, it's good. I mean, I could. Yeah.
And then put it back on there when you put it in.
This is not very easy. The other problem I think we'll be having is because we're using zip ties, this thing will slide back and forth. It needs to be further drawn. Yeah.
It will be.
So when this gets to this position, it'll be off balance. So I ordered this belt here, and I think we're going to be able to make our Rotocaster work for a little bit. And I'm going to put that together now.
Oh, I'm sorry.
But if you want to know, I can tell you.
No.
That's so that when we get this in here, we get it through, slide through. So. Stay through there as we're taking it.
It's got to stay
In that hole. Otherwise it won't fit. Now,
everything out?
Yep.
Where's my dryer? Put it right in there.
Alright.
Oh, you brought some wood.
Now,
Doesn't need to be tightened up.
no, so basically we have the bearing in there and that little thing on top. And then this will go into here.
Very nice.
That's what I'm thinking. It doesn't need to be so far over here.
All right, I wish I could say more.
Alright, thank you.
Centered in the frame. Centered in the
Frame.
This is gonna upside down. Okay, so we're putting on the last of this gear up here. Basically, I drilled this block into place, and now we're tightening it down. Is I'm going to thread this on here so I can get it to the point where it start to stay. Take it off. About all the way as threaded as much as we're going to get. Go ahead and lock that down. Lock this side. That's about as much as we're going to get there. Down, and then lock this last nut. Alright, now I need to get the rest of this tightened down here. I can take off some slack there. Tell you what, this build is not for the faint of heart, let me tell you. This thing is a challenge, especially when we're not using the wood that Mark Schultz asked us to use, which is 1x3s and 1x2s. These are 3/4 by 2s and 3/4 by 2.5. This guy is going to be about that far. We're going to have a net on the end, right about there. Give it a little extra space. So, now that I've got this in position, it's about 1/4 of an inch off. That was not good at all. I didn't expect the whole thing to come out and slide out. Okay. Well, okay, so this is my Rotocaster that I'm building, and I had ordered a belt to help drive this thing, but it did not work, it did not fit the right way. So I am going to go try to put it together again and get this rolling, because I finally ordered the right belt. So this is my belt. The other belt was off by 1/4 inch, so I'm hoping that this is the right one that fits. So I think what I'm going to do is also set up this other camera. Alright, now, what we'll do is see how this belt fits. Alright. So, now with the proper belt, it works, but obviously, yeah, looks like we need to cut some off of that side there. So, let's go ahead and get that started now. So I have this belt that's working now, and basically with this transmission here, as the thing goes around, it's actually turning the panel where it needs to go, but it's also kind of top heavy, so I will have to create some weight that would take off that bit. But I have this belt now that's actually doing the work and actually turning the gears for me right now. So yeah, that's looking good. Alright, there we go. Floating a little bit better. Alright. So we have the belt turning properly. So the idea is that if we turn this handle, it's going to turn the mold. But what I need to do is I need to put some weight on here to counterbalance all the stuff that's happening over there. It'll be interesting to see just how much that weighs. So I'm going to use my little scale here to determine how much weight do I need over there. And we're going to alright. So let's find out.
280 grams. Something 280 grams. Okay. Then we'll be yeah. Now I can turn that with my hand. It's a little bit hard to turn before, but it's not too bad. All right, so that is what needed to happen for that. So the idea here is what we need to do is we need to take this mold of mine and open it up, pour the material in there, get it here, pour the material in here and here, and then slap these two together, and then once the material's in there, we're going to slap this in here and get this balanced as best we can. What I was going to do is, anyway, so that stays there. Because I'm going to have a limited amount of time to play with the material. The material I'm working with has what they call a pop time of 42 minutes. So once I get the material in there, then we're going to put it in here. Probably it's going to go like this. Alright, so maybe not like that. The idea is that this machine will sort of do this to the mold while it's got the material in there. So I'm going to turn this around and see if I can get this to fit where it needs to go. Unfortunately, it's too big. So what I'm going to have to do is modify these hole areas to match. So the original specs for this machine called for a 10-inch sandwich. I made it a 12-inch sandwich. Hence the problem. 12-inch sandwich because I got a really big mold. I don't even know if this is going to work, but we're going to give it a shot. Go anywhere.
Here, let me try it. Is it okay?
Yeah, yeah. And this, supposedly, fit inside here. So here's another idea I had. Since we're only working on this mold here, we're not going to be working on any other mold anytime soon. What if we did like we're doing, saying, but I get some 2x4s and I actually create an inner frame like here and here and here, and we run our bolts all the way through it, through those frames.
Oh, you mean take this out, remove this?
Yeah, we remove this bit here. Well, actually, we are going to use it, but it's actually going to be attached to this frame in a way that's centered. So, for example,
How tall was this thing?
it's 12 inches. This is actually it's actually about 11 inches.
11 inches, and how tall? What's the space between here and there?
It's 12. So, like for example, if I take this guy and just set him on, if I take this guy and set him on the bolts by themselves,
If it were resting on the bottom of that frame, would that be okay?
no.
Okay, it needs to be up suspended.
Well, it probably
Split it as far as the
probably
bounce.
would be okay. But I'm thinking that if it's all, yeah, that's 3/4 now. That's almost 3/4. So 1 3/4 inch frame that sits out 1 3/4 inch, and basically is attached through here, so that, let's say we put a 2x4 all the way across here. We put a 2x4 all the way across there, and a 2x4 all the way across here. That's attached to the frame, and then we, let's see, maybe not a 2x4. Well, I'm just trying to think. I just don't want to keep on adding weight to this.
Right, right.
The other thing I've seen the other guys do is actually drill holes through here, so that this all is solid.
Instead of having all this frame.
Yeah.
Yeah. Yeah, I was just trying to figure is there any way just to put the mold, have the mold in there attached, from before. Where I was going is that, you can get these bolts that basically one end sticks into the mold, and you just wind it out. It's tension. So in other words, as you back it out, once you set that thing in and you just back it out, it's tension that way and you tension that way. So one thing you've got is
Yeah, but it won't work because it's got to be offset. It's got to be sitting this far out on each side.
Oh, this does.
Yeah.
Why is that? What am I missing?
Because it's that wide. I'm thinking about making a frame that it's fit like this together, like wide, so that we can actually drill our bolts all the way through, attach them, and secure them with nuts here, so that would essentially these bolts would provide the. In my mind, it's working, but.
Yeah, well then you don't have to explain it to me. I'm not sure. I might solve it totally different, but I'm trying to follow you visually. But if you've got something that you in your mind you think will work, then that's what you go with.
Hang on, let me turn off this camera. Okay, so what I'm doing is I got some wood blocks here. I'm going to drill on this drill press right here, and it's going to be making a frame so that it will fit the board. So that's what I'm working on now. You have the same idea I had? Just going about it a different way?
Yeah,
I'm going to start using.
yeah, pretty much. One of the ideas was a little bit radically different than that, but of the two, that one's very similar. I just wasn't going to use a whole block. I was going to use one chunk.
Yeah.
But the idea is that it stays balanced and symmetrical.
Right.
But that's I think I might like yours in better. As long as it don't add too much weight. All right, be back in a little bit.
All right. All right. Forgot the washers. Mold needs to sit downwards. Makeup for the. All right, that's where it should lie. These are fishing lure, fishing weights. that I smashed down. So I'm going to go ahead and put some drill holes through there and attach them. Nice. Now, so a neighbor of mine was getting rid of a treadmill, and I'm here sort of taking it apart. What I want is this motor right here, and it has a variable speed, so I'll be able to use it. I got to take all that and put it in a box of some sort, so that I'll be able to control it and be able to turn up the speed and turn it down and sort of keep it at that speed. So I hope that we can make this work. Okay, so I'm here trying to figure out how to now hook this machine, this thing, basically, that is now balanced with the mold inside. I need some way to drive this little thing here, because I can turn it with my fingers, but really only so much. So what I've been trying to figure out is a way to drive that. And what I need to do, is figure out some sort of gearing system. There's lots of different ways you can do this, but I'm just trying to do it a little bit on the cheap because I don't want to buy a motor. So a friend of mine was giving away a treadmill, and it still worked, but it was old and everything like that. So I asked him if I could have it, and he said yes. And I asked him if he didn't mind if I take it apart, because I wanted to salvage the motor out of it. I wanted to salvage the motor out of it. So here is a motor. Here's all the parts and pieces. Motor. This was attached to, this is the flywheel. It basically just screwed right off. And there's the screw there. And so this is the motor. It does 5,000 RPMs. I only need it to do 10. But luckily, all the electronics work, and so I can use this dial to dial it way down. And so hopefully I can be able to use that. So what I'm going to do is, maybe I took the dimensions. Oops. There we go. So what I did was I took the dimensions off that drive screw on the treadmill motor, and I brought it into my into my 3D program, and that basically I use for my video editing and stuff like that. But I was able to make a screw that I done somewhat. Well, anyway, let me show you this. So initially, what I wanted to do is I wanted to create some sort of drive system, and on Thingiverse there was this sort of these two things here. See that? So basically, if you turn this, the gear will turn slowly. So basically, this going fast will make this go that much slower. So I said to myself, well, what if I create some sort of collar when I initially printed it up, it looked like this. So all the scaffolds in there. When I printed a little bit slower, and I was able to get all the scaffolds out there and print it without any issues. So what I said, well, maybe what I can do is make a collar that goes around that drive and then attach this to the other side. Well, my first print didn't turn out very well. Here's my second print. Here's my drive. And so if I hook that up like this and drive it, I know this is not working very good right now. Anyway, that's the way it's supposed to work. I'm hoping that I can make some sort of drive system and some sort of apparatus that will fit right here that will drive this screw. So we're going to try that out now. I know this is a lot of work to go through to do this stuff, but what I wanted to do is, rather than make just a rubber mold, like when I made this one, which is, I basically poured it in from the top, it filled it up all the way hard. Now, it is rubber, and there is some pliability to it, but I wanted it to be more like this. So, to have some air inside, and then be pliable. So imagine this rubber if there was hollow inside. If it was hollow inside. So what I want to do is I want to pour the material in here into the mold. Do this until it sets up, and then it will be hollow inside of this silicone model. And I'm hoping that that will be what we need to have. It should fill in all these crazy holes that happened, and I hope it all works out. But I'm thinking that it'll be a good project, and hopefully it will be able to do it well. All right, wish me luck.
See how it turns? And it rotates on both axes. Look at that. Check this out. He's got a motor, what used to be from a treadmill, and then over here he's got like a little control board. You can check the speeds. It's also just a mock-up prototype now. He's printed a worm drive here to go with this. Oh, and the end product are these guys. That's the idea. He's making brain stems. See? Yeah, if you turn to your right, Rick. See his brain stem? Yeah. Okay. Alright. Alright, let's see what you can do here.
Well, I might need your help. So I got this recording now. So what we're going to do is...
Okay, so he needs my help.
It's alright. So we got this worm gear. And I'm going to turn this on so it should start to go. Looks like this is where the speed was that we were doing. I'm gonna make a little mark, but it looks like you have to crank it up some. Seems like you have to go fast in order to bring it back down to where it needs to go.
So that means it's how much voltage is it with minimum? Is it getting? Does it say 100 volt DC?
So what we could do
14 amps.
Is put this on a little sliding, like a little pivot. And once we got it in place, then we can put it back in where it needs to go. Once we got it going.
Oh, you're saying as far as it like not making it'll never have a constant contact. It'll actually be the motor will start to turn while it's disengaged, and then you will engage it, sort of like a clutch.
Yeah. So otherwise, we'd have to figure out something that basically will turn on when you want it to turn on.
Okay. Just keeps getting deeper.
Well, anyway, let's put this up here. And
You need constant tension.
yeah. That's why you need some sort of jig.
If this was mounted and then you could pivot it,
Right.
you could just bring it down.
Right. It's engineering problem after engineering problem after engineering problem.
Turn that camera off.
The engineering problems never stop. We have to keep on going.
Man and his 6 simple machines. We need the lever, we need the wheel, we need the pulley.
So so what I was also thinking is that maybe we can, create some sort of apparatus that would sort of sit here, and that would house the motor. I mean, honestly, this motor is way too fast for this device, but it's what we have right now. So, this idea, great idea, but not going to work. The problem is that this motor goes way too fast. So this motor goes way too fast at its slowest speed. So turning this turns okay. Let's see. This turns okay, but it really needs to only move like at that kind of speed, really, really slow. I would like to get it like 6 rotations per minute or 10 rotations per minute. In order for me to find something like that, I need to find a different motor to put on the end of here. So I'm probably going to take that off and find me a different motor. What I'm thinking about maybe is a can opener motor, something that's got a really strong torque, goes really slow, something like that. I'm going to go to the junkyard, or to the thrift shop or something like that, see if I can find one pretty cheap, and take it apart and see what we got. So there we go. Let's see. Well, I hope we can get it to working. So the treadmill motor that I had, which is this guy right here, is going to be way too fast. So I went back home and I got myself my my rotisserie engine. So basically, this is what this guy right here is what I'm using to grill chicken and that kind of thing, and it has 2 rotations per minute, and I think it will work for this thing pretty good. So we're going to go ahead and try to get it mounted and see if it'll work.
Rick's on the camera and he's got his Rotocaster. Look.
I got my rotisserie machine. It's working!
Good job. Check it out. Unbelievable.
That's the way to do it.
Good job, Rick.